Welcome to Unite Now, where we bring unity to you, wherever you are.
Hello, thank you again for joining the second part of the Unity Tip session. If you haven't watched the part one, please make sure that you do. The link will be in the description below. Today, we're going to talk about Unity tips for optimal performance. We're going to focus on graphics, audio, and the UI. My name is Arturo. I'm a games evangelist at Unity Technologies. Please feel free to reach out to me on Twitter. That's my handle down there. Share your optimization tips, your thoughts, and your feedback. If you want us to continue working on similar content, please also let us know. This is the agenda for today. It's shorter, but hopefully it's going to be useful and fun for you all. We will talk about some tips about graphics, UI, audio, as well as importing tips. Let us know what other topics would you like us to cover in upcoming videos. Okay, let's start with the asset importing tips. So, you know that a common cause of large build sizes comes from unoptimized import settings, in particular in assets such as the textures. So, using incorrect settings for particular projects might yield in unnecessarily large build sizes. Also, long build times and the poor memory usage, as some of the info in the texture won't be really used. So, here you can see that we have two scenes, one using the same 3D model, the same texture. The one on the left has some settings such as the generate map set to true, the max size of the texture is to 2K, the compression here favors quality, and you can see that the disk space that we're using is 5.3 megabytes. On the right side, we have the same texture, the same model, we have maps. We just changed a couple of things. One is the max size is just 1K in this case, and we're favoring the compression to be more aggressive. So the disk space here is 0.7 megabytes. Now, the question that you have to ask yourselves is, do I notice any difference? If I do, then probably I have to tweak some values to do like some trade-offs between disk space that I'm using versus the visual quality. Remember, it heavily depends on your project, and you have to profile and evaluate the performance versus the visual quality. But some general recommendations are these for texture import settings of your textures. So try to use the minimum possible value for the max size setting in a per platform basis, because in some platforms you might have more memory, etc. So just consider this. Also, make sure that your textures are POT, meaning power of two in size. So that's important because some compression formats won't work if you are not using power of two. In any case, try to atlas your textures as much as possible. Remove the alpha channels on background textures or other opaque, meaning non-transparent textures as well. Also, unless you need to access the data from the texture from code to maybe modify the texture, try to disable the read and write enabled option just for memory usage sake. Also, examine if a lower format like 16-bit is enough instead of a larger 32-bit color format. If you don't need maps in cases such as sprites or UI elements or anything that won't change its position relative to the Z value from the camera, just disable the maps. Now, onto a similar topic, but in this case, import settings for meshes. So you know that 3D assets import settings and an unautomated import pipeline might yield to some errors. And I'm saying unautomated because usually when you import a mesh, you manually change the values there. There are options to make this automatic, but in this case, we will assume that we made some mistakes or because we don't know what's going on. We selected the wrong import settings. So this can yield to large build sizes, poor memory usage and at runtime. And again, this can be due of incorrectly set settings in our 3D models. So make sure that your assets are correctly important and that the quality due to compression doesn't make your game look bad, because that's the important thing here. These are dependent on your platform or on your game, etc. But here are some recommendations and why. So try to optimize the mesh try to use a more aggressive mesh compression to reduce the disk space. However, notice that the memory at runtime won't be affected by this setting. Also disable, if it's possible, the read and write enabled option, as if you have it enabled, it will make Unity to keep the 2 copies of the mesh. So basically you're having twice the memory footprint at runtime. If you're not using animations, then disable rigs. This is true for objects that are not going to be animated, like a rock or a house, etc. If you're not using blend shapes, also disable them. Regarding normals and tangents, if your material won't use them, just disable them to save the cost of the extra information per vertex. Now let's talk about graphics. And graphics is one of my favorite topics in Unity and in computing in general. So let's see what we have here. And remember, if you have suggestions, if you want us to make a video and go deeper into any of these topics, let us know in the comments or via Twitter. Okay, now on batching. And this is something that we hear all the time. And basically, when Unity renders our games, it submits what is called, or what are called, draw calls. These are submitted to the GPU in order for our scene to be rendered. The more objects, the more materials, and the more textures, the more processing is needed to display our images. So that's pretty straightforward. So submitting too many commands might be detrimental to our game's performance and will have a bigger impact on games that are already GPU bound, meaning that we're already stressing a lot the GPU in our game. So the solution here may be pretty obvious, but don't worry. This is, I would say it's not pretty obvious at first. The solution here is to send as few rendering calls as possible, meaning that we will be batching more of those together. There are a few things to consider when batching. For example, objects that can be batched together need to have the same material reference as well as using the same texture. And remember, in the previous section, we were talking about atlasing of our textures. This is where this also becomes important. In Unity, we have two batching techniques. One is dynamic batching, which might help you reduce draw calls on moving objects. However, there are some restriction to its use. Like, it only works on messages with less than 900 vertex attributes, counting position, normal, UV0, UV1, and tangents, etc. Dynamic batching, it's evaluated once per frame, and this goes in the CPU. The other one is static batching, which attempts to batch game objects with the static flag enabled. You know, if you go to the inspector and you set the static flag there for batching, this is done at build time, and this is recommended to most projects, static meshes, meaning that anything that won't move should be marked as static. If you add static geometry at runtime, for example, maybe you're working on a runner or something like that, and you have to instantiate geometry that will be static, take a look at the static batch utility.combine API. So you can see here in my screen, well, it's the same scene. We just have two different configurations. The one on the left uses a different material and a different texture, and you can see that we are submitting, or we have two batches to render. On the right, we have the same material and the same texture, and we're just submitting just one batch. And I'm using here the same model, but this will be true if I had two different models, as long as the two rules here of having the same material and same texture are the same. Cool. Now, about disabling shadow casting, and again, it depends on your game. I'm not saying like go and just don't have shadows in your game, because you need shadows in most of the games. By default, a new instance of an object with a mesh renderer component will have the cast shadows property activated, and this is to improve realism and depth to the game's lighting. So having that shadow rendering passed might be unnecessary in some cases. And in complex scenes with multiple objects, this will cause an unnecessarily computation of shadows that will end up not being visible. So here the recommendation is to disable the cast shadows property from the objects whose shadows won't add any relevant detail to our scene. If you want to see what's going on in the frame debugger, look at the shadows.draw step. So you can see here in this example, we have the same scene, this camera set at the same position, etc. On the left, we have the cast shadows of the barrels is on. On the right, we have them turned off. See if there's any difference, and also make sure that when you are profiling, your camera is able to look at that, because maybe the shots that you will have throughout your game won't even catch the shadows there. So you can save some CPU cycles by not computing the shadows. In some cases, these might not make any difference, but in some cases, you might want to squeeze those small cycles to just optimize your game in general. Okay, the next one is on calling masks for lights. And we have discussed like layers for physics or layers for rendering, etc. In this case, we're using the same layers, but for lighting. So in complex scenes with multiple lights that are close to each other, you might encounter that some lights shouldn't affect certain objects, etc. So you can optimize that. And depending on the renderer pipeline configuration, the more lights that you add to your scene, the less performant the game is going to be, because you are basically adding more complexity. One way of optimizing this is just to make sure that each light only affects objects in specific layers, especially in places where multiple objects and multiple lights are closer to each other. So in this case, you can see that I have two light sources. One is the directional light that is affecting everything in my scene. The other one is a point light that is only affecting my player layer, or my player layer, which is the llama. Perfect. So the next one is to avoid mobile native resolution. And you know that the latest mobile phones resolutions are pretty high. In some of the latest iPhones, you can go to crazy resolutions. So displaying that resolution on mobile might cause performance and heat issues due to the high number of computation involved in processing things such as the post-processing, etc. If your game is already suffering on the GPU side, maybe this is going to make the problem even worse. So here the recommendation is that you can lower your game's default resolution with the screen.set resolution function and gain some performance. You need to keep a balance, because if you go too small in the resolution, you might end up with a low quality image. So you don't want this. So remember, make sure to profile multiple scenarios and find the sweet spot, even maybe on depending on the device. Great. Now on some user interface tips. And again, this is more on the not on the design, but on the performance side of UIs. So hide invisible UI elements. And this might be like pretty obvious for 3D, that if something is not visible, maybe we shouldn't have it active. In some cases, you do, but in UI, this is important. So having UI elements not present on screen, meaning they are not visible to the camera, maybe like a health bar that only shows when an event is triggered, such as you being hit or something. The problem here is that the camera cannot call this. So the object will be rendered regardless of not being visible. So if you have this scenario, just disable any non-visible game objects to prevent unnecessary calculations and rendering as well. Back to this batching word. And remember, when we are designing and implementing our game's UI, we have the option to have one or multiple canvases. Some of them might have content that rarely changes, such as a health bar, and other elements might be changing every frame, such as a timer. So having a UI element changing its value or position breaks the batching, meaning that we will be submitting more draw calls into the GPU. The recommendations here are pretty straightforward. It is recommended to separate your UI elements in different canvases based on how frequently you update them. Also, all the UI elements within a canvas should have the same Z value, not to so you don't break the batching. They need to have the same materials and textures. You can animate your shaders or your materials, and these won't break the batching. So if you need some effects there, you should be good to go. And the objects should be using the same clipping rate. Then on the graphics raycaster. The graphic raycaster component is used to handle input events, such as a touch or a mouse on any UI game objects. Sometimes objects that should not be interactable are still part of the canvas that has the graphic raycaster attached. So every time that an input, such a mouse or touch, is triggered, there's an iteration over all the UI elements that might receive the input events. And this yields to a point inside rectangle intersection check to see if the object should react. In cases where we have complex UI, the computation for this might become expensive. So here, the recommendation is to make sure that only your canvases that are interactable have the graphic raycaster component, just to save some CPU time and avoiding unnecessary evaluations. Another one on UI, and this time one on full screen UI. So in certain games, the pause menu or other full screen UIs occlude the geometry and other UI elements. For instance, here in this example, we have the maybe the pause menu or something like that, and we are not showing anything from the 3D world, right? There's still a cost of CPU and GPU, even when the objects behind that are not visible. So the recommendation here, or the recommendations here, are simple, just to save CPU and GPU. One is to disable the camera rendering the 3D scene. So if nothing is going to be visible, just disable that camera. Hide other covered UIs. If possible, disable the canvas component, not the game object itself. This is just to save some processing when you want to make the canvas visible again. And also, if possible, reduce the frame rate when possible. So if you have UI that's just for menu and it's not even animated, or the animation is at 15 frames per second, there's no need of running the background animations or the game update at 60 frames per second. Now, some audio tips. So, it's very common that audio clips are imported and configured in an incorrect way in the editor, either because of the lack of knowledge of the hardware or the formats, or just because there are some flaws in the importing workflow. This usually yields to poor memory usage at both runtime and in the packaged file. Also, not taking full advantage of the underlying hardware for the compression. So the recommendation here is, whenever possible, set your audio clips option to be forced to mono. By doing this, you will be saving around half of the memory space and disk space. If you need additional compression, you can reduce the compression bitrate. However, just make sure that it doesn't destroy the quality of the clip. And a quick guide on how to configure your audio settings is here on the slides. So force to mono when possible, reduce the compression, use these formats on iOS and Android. And regarding how the load type for each one of our audio clips, just make sure that a small clip is set to decompress on load. It has to be less than 200 kilobits, because there are some internal memory management issues that anything beyond that will still allocate those 200 kilobytes. So anything below that should be to decompress on load. Something medium, meaning larger than 200 kilobytes, should be compressed in memory, and large files, such as the background music, should be set to stream. Another one on audio is to don't stream the audio if we are muted. This means that most games, or virtually every game, implements some mute function, right? Which basically mutes the SFX or music in the game. But in many cases, developers simply turn down the volume either on the audio source or in the mixer. Here, the problem is that this implementation may yield in unnecessary memory usage and CPU time, as just turning off the volume doesn't deallocate any memory related to audio or any other function calling related to playing the actual audio. So the recommendation here is to unload any audio related source from memory, or any audio clip from memory, as well as having a high-level manager that helps skipping calls to any audio-related API. So for instance, here we have this flag that we say if the game is muted, then don't play X audio or something. Also evaluate here, and this is important, what's the cost of unloading and reloading the audio sources again. So and also check how often will the player be doing this, because maybe for your use case, if the player will be turning on and off the audio too often, then probably this is not a good idea. But in general, this is something that players won't be doing every frame. Awesome. So that's it for the second edition of the Unity Tips presentation. Don't forget to follow the Unity Tips hashtag on Twitter for new tips. This is every Tuesday, and also share your tips on Twitter. I recommend you to watch this Unite Now presentation on profiling by my colleague Chiro. And please reach out to me on Twitter. Let me know if you like the presentation, if you have tips, or if you would want me to dig deeper into any particular topic. So that's it. Thank you and have a good day.